My pleasure. Take care. Good.
Bye-bye.
Now, bye-bye. For our next talk, all right, we've traveled from India. Now we're traveling to the United States to be with Sébastien Pahl. Sébastien doesn't need much of an introduction. It's kind of a big deal. He's also been on our meetup already, giving a talk about his brand new startup called Obstrace. Interestingly, that we just finished with Divya talking about observability. I imagine that will be mentioned somewhere along the course of your talk. Sébastien, it's all yours.
Hi, thanks for the intro. Thank you very much. All right, so let me share my screen here. All right. I'm very happy to be here.
Us too.
All right, so there you go. So let's see. Let's make this.
Yeah, make it full screen. Yeah, good.
Yeah, it's coming.
Perfect.
All right, so hi, I'm here to talk. It's a very short talk, so we're going to get through this and maybe talk about a few questions at the end. I'm here to talk about why we need something like an open source observability distribution. Of course, we're building one, but there's probably other people that are building similar things. In the end, open source observability is awesome. You can do many things with it, and it's catching up with the SaaS providers very quickly, but it's too damn hard. It's very hard and requires a lot of work. So I'm going to go through a couple of things. It's a very basic talk. What needs to be done if you want to monitor a Kubernetes cluster? And I'm going to stay at the high level because we don't have much time to go into the technical details. So who am I? I'm Sébastien. I'm the co-founder and CEO of Obstrace. We're a small, young company. We're 2 years old, and we're building an open source observability distribution, obviously. Previously, I've worked at companies like Red Hat, Mesosphere, and Cloudflare, and I'm a co-founder of .cloud, which became Docker. So Solomon and I worked together for years on containers before it was a thing. But I'm not here to talk about containers directly. I'm here to talk about how we monitor them today. So, what do you need to monitor a Kubernetes cluster? Obviously, it's very basic. The first thing, you need a Kubernetes cluster. That sounds easy, but it's not. That already requires quite a level of knowledge. It's easy for people that are probably joining a lot of these talks and doing, but over time, it takes a lot of work. So you already have your own Kubernetes cluster, and then you want to monitor it. You need to collect metrics, you need to collect logs, you probably want to do tracing. Not everybody is ready for tracing, but this is something that's quite useful. So how do you get there? So for metrics, you're probably going to be using Prometheus. This is a CNCF talk, and Prometheus itself is kind of the de facto thing that you want to use to monitor a Kubernetes cluster. But how do you set it up? One of the very cool things is the Prometheus Operator that I recommend quite a lot. I'll go back to the presentation. But the Prometheus Operator is something that will allow you to deploy Prometheus into your cluster, and instead of having to configure Prometheus itself by configuring its config file directly every time you add a new service to the cluster, the Prometheus Operator will allow you to add Kubernetes objects that are called service monitors, so that you can point to your existing Kubernetes services. So that already makes it very easy and to use Prometheus in a Kubernetes cluster. But what about long-term storage? Okay, you have Prometheus set up, it's writing to its local disk. Well, then you need to add other options. You want to keep your data for a year or two or more, or maybe even 3-4 months. You can do it on the local disk. That's good if you have a small Prometheus instance and you don't worry too much about reliability. Otherwise, you're going to have to either set up redundant Prometheuses, that's one thing, or you're going to want to write long-term to some long-term storage. Two of many long-term storage options for Prometheus are Thanos and Cortex, which allow you to write to S3 directly with your data instead of to the disk. This also requires some setting up and knowledge to learn to get to. So every time you want more out of open source observability or metrics, you need to learn more, which is fine. That's the compromise you do. Instead of buying something, you get to build more with the blocks that are out there. Logs are a bit the same thing. Fluentd, FluentBit, are not, no need to mention them too much. They are also CNCF projects. You need to know how to set them up. You need to deploy them in the various clusters that you have. You need to understand its config file, how to extract labels, and then you need to store it somewhere. So what is it going to be? How are you going to do centralized logs? Most commonly today, people use Elastic or maybe eventually the new OpenSearch that people are rallying behind. But that also requires disks, it requires money, it requires knowledge to scale it. It requires, again, how do you set it up in another Kubernetes cluster by itself? Do you pay for it? Same for Loki. Loki is very cool. Loki allows you to make it much. It's a younger project. You can. It's more like a Prometheus of logs. It is really cool, but you need to set it up. And but once it is, and once you've learned it, it's very powerful. You get to use something called logql to query your logs, to check, to basically have a distributed grep over everything, and it's much more cost efficient than, for example, the current Elastic approach, because the logs themselves are stored, again, like Thanos and Cortex, in S3, which is much cheaper over time. Tracing, well, tracing is an even more complicated beast. So as soon as you go into the world of tracing, not only do you have to modify a lot of your code, which is fine, like it takes time, but people will get there over time. But then you need to store those traces somewhere. There's cool alternatives from Grafana Labs, akin to Loki and Cortex, that store things in S3. But the way to do this to date is to set up Jaeger. And Jaeger needs to be also backed by some long-term storage. The recommended way of deploying Jaeger is using things like Kafka and Cassandra. That is not trivial knowledge. That is also something that is not easy to deploy. So thankfully, that's why we have things like Tempo that are coming up. But even once you have all of this, what's left? You need something like Grafana to visualize your data. So people know that you deploy Grafana in your Prometheus account. You need to start setting up your alerts with Alert Manager. That is another thing that you need to learn. But once you've acquired that knowledge, you can use different ways, the different ways that Alert Manager helps you to build things like SLOs and error budgets. But then one more layer down, you need to also make sure your code sends metrics and logs and traces to the system. So you embed code into these, you embed libraries like either the Prometheus libraries, or you use Prometheus exporters, Prometheus loggers. Sorry, not Prometheus loggers, logging libraries in your code to extract all that data out of your code. So that's everything you need to do when you want to set it up yourself. It's a lot of Terraform, it's a lot of YAML. It is something that companies set up entire teams to do. So that's great, but it's not there to serve the end user. It's not there to serve the people who just want to get started. They don't have another choice of either learning everything that I've talked about in a very, very quick manner, or to use something like a SaaS, like Datadog or something else. So our goal, not at Obstrace, but I know a lot of other people that are doing it as well, is to make it very, very easy. I skipped even a few things here because I'm skipping ahead, but how do you set it up with security? How do you make sure that you have authentication, authorization on top of all this? None of what I've talked about before implies any of that, because by default, it's left as an exercise to the user. How do you make sure that you keep it up to date? And how do you make sure that everything is tested for correctness, for scale, when all these open source projects move at a lightning speed? This kind of is starting to get solved in the world of deployment, continuous deployment, but for monitoring, you kind of on your own. You have to still do it all yourself. We're trying to do another way of basically putting it all together. We're building one bundled way of deploying it all in an external cluster. And this external cluster basically allows you to monitor and have all the things that I've described before deployed automatically. So I don't want to get too much into what we've built. I want to mostly talk here about why we've built it. We've built it because of all these difficulties. We've built it because you need teams to do all of this. And what we would like is people to not rebuild all of this again and again in their own companies and again in their own corner, but basically get behind either ours or another project to make sure that everybody doesn't have to rebuild these things again and again, to kind of democratize open source observability and make it as easy as SaaS is today, right? But without the costs. So we've done this by building a big CI, test all of these projects together. I encourage people to take a look at it. And all I want to do here, since we don't have much time, is open the discussion. How do you basically do this? And how do you want to keep doing this over time as open source observability is moving faster and faster and faster? So that's it. Thank you very much.
Wow, that was good. That was so good that we still have a little bit of time.
Awesome.
Now, historically speaking, as someone who's very much involved in, been involved in containers for a long time, how do you see the changes that are happening right now with everything that we're talking about today about running data on Kubernetes and what it means for the future?
Mm-hmm. So as I showed here, there's an explosion of the amount of complexity and software that is used in any domain, right? I've talked about observability, but the same is true for CD. The same is true for continuous integration, for all kinds of data operations, right? Like whether you use things like Kafka or things. So what's very exciting is to see, I've talked about it before, more and more programmable interfaces appear, right? And they've been appearing for the last 5 years. This is why these things are possible, to start doing this with code and with less manual work, right? So that we can stay focused on our work and on the things that we are actually want to build, right? Every company has an actual thing in mind. They don't want to rebuild all this tooling. Engineers do it because they have fun doing it, right? And that's great. And then, I'm just happy that there are more and more programmable interfaces, to just give a very blunt answer to help with this.
Okay, good. And in terms of the trends and things that you're seeing regarding observability, like you said, there are more folks that are getting into this space. What do you think that means? That like I said, do you feel that this is promising, that this is becoming more important?
Yeah, open source observability is becoming more important, I think, because the vendors, whether it's Amazon, the other observability vendors, or this are basically pulling everyone to try to use things like OpenTelemetry, Prometheus, to try to create a common fungible base so that they can all kind of sell to all of them together. And it's not just because of that, it's also from below, like people are building on top of open source. People are deploying on Kubernetes, on things, using things like Terraform and all these things. And Prometheus, all the OpenTelemetry is getting built into all these tools. So if you want to utilize the same thing in your stack, in your own stack, as the stuff that you're built on top, you kind of have to adapt. So open source observability is kind of has a good future, but it's very complicated. I don't know if what's going to be the winner where, and that doesn't really matter. What matters here is that people don't have to basically change their libraries all the time, right, to go to the same vendors, to different vendors and rewrite the code. I hope that people that think that, well, basically code will get more instrumentalized. And I think that thanks to these open source pushes, it will be.
I think that's a very healthy thing, that there is that open source push, so that people are not only left with the proprietary sort of options that are out there.
But don't get me wrong, we're far, far, far behind these SaaS offerings, right? SaaS is super easy. You just go, you click a few buttons, and it works. It's expensive. It has other problems.
But anyway, very, very good to see. Yeah, very, very good to see open source companies like Opstrace fighting the good fight, getting out there and pushing for the right thing. Sébastien, always great to have you on here, and looking forward to have you on another meetup soon. Thank you.
Thank you. Have a good one.
Cheers. Bye-bye.
Everyone. Bye.
As usual, we can continue the conversation both in the chat that's on YouTube as well as in our Slack. Sébastien, as you know, is a very